طيب last time شباب we talked about the hydrogen mobility, and we have seen that the application of the hydrogen for combustion in internal combustion engine will result only in efficiency about 30%, and also it may result also in NOx emission. And we said the ideal replacement actually is to have the hydrogen in the fuel cell. Fuel cell actually can result in an efficiency, it can be approaching 65-70%. With the hydrogen, and that should be actually the ideal replacement for the hydrogen in the internal combustion engine. We talked last time also about the different part of the hydrogen fuel cell, and I think you have idea about this. We have the anode and cathode. It looks like a battery, but it is not a battery. We have in this case, we have chemical reaction where we have hydrogen is reacting with oxygen to produce water in addition to the electricity. So between the anode and the cathode, we should have the electrolyte. We talked last time about this proton exchange. We talked last time about the proton exchange membrane fuel cell, hydrogen fuel cell, in which we do have between the anode and the cathode, we have the electrolyte is a kind of membrane. So this membrane, shabab, we have the catalyst at the anode, which can actually ionize the hydrogen to hydrogen positive hydrogen atoms or hydrogen ions. Those hydrogen ions are allowed actually to pass across this electrolyte membrane to the cathode side. And due to the catalyst and the ionization, we should have actually some electrons should be freed. This membrane shabab, blocks the flow of electron. The negative charge actually part is blocked to pass through the membrane, so we can have it through an external circuit to generate electrical power, and then we can have the positively charged hydrogen ions. They can transfer to the cathode side, then they can react with the ionized oxygen as well, which is coming from air. Then it can produce H2O. So the general or the overall reaction for this fuel cell, shabab, hydrogen fuel cell, this fuel cell proton exchange membrane is the most common hydrogen fuel cell, which is actually more prone actually to be applied for the case of vehicle, running the vehicle and the buses working with hydrogen fuel cell. So the overall reaction, we have half oxygen. Oxygen is reacting with hydrogen in overall to produce water vapor. This is very clean water. And that's why shabab fuel cell can be used also in some application to produce some drinking water. This water is not any drinking water, it should have some kind of salts and some other materials that can be added to this water. So this is high purity water that we can have actually different uses. We have different kind of fuel cell. I will just go roughly about all of this kind. Most of them, the main difference is the electrolyte. We have the alkaline fuel cell. In this fuel cell, we have in this case the electrolyte is liquid electrolyte, not a membrane like the proton exchange membrane. This is a liquid electrolyte, which is sodium solution actually of potassium hydroxide, which is actually soluted in water. In this case, shabab, the ion in the proton exchange membrane, the ions that transfer across the membrane are the hydrogen, positively charged hydrogen ions. In this electrolyte, actually, what transfers across this liquid electrolyte is the negatively charged OH ions, which transfer from the cathode to the anode in this case. This OH will be just ionized from the reaction at the cathode, oxygen plus water vapor. In the presence of catalyst, we can produce those ions. Those ions can transfer across the electrolyte. So the electrolyte will allow also the transfer only of OH, negatively charged OH ion. It will transfer to the anode side where we can have the reaction with the ionized hydrogen to produce water vapor. But water vapor in this case is produced at the anode, not at the cathode. And also the electrolyte, its main function is to block actually the flow of electrons. Then we can have the flow of electrons, we can have it through an external circuit to generate electrical power. Usually fuel cell, hydrogen fuel cell, all of them, they work actually at little bit elevated temperature to have this reaction activated, and also to use little bit cheaper catalyst, because at low temperature we have to have actually high price catalyst in order to activate the reaction to ionize hydrogen and also to ionize oxygen, and then we can have such a kind of reaction. يعني this kind of alkaline fuel cell يا شباب have يعني a reasonable power output, electrical power output, and it was the first one. It was used in the Apollo space aircraft. In the Apollo spacecraft, it was used actually to provide electrical power and also to provide some drinking water in the space. So one of the uses of the fuel cell, it can produce actually high purity water at the outlet. But one main disadvantage of this شباب alkaline fuel cell, its sensitivity to carbon dioxide. So usually we have the atmospheric air. This fuel cell is just a supply. It takes the oxygen from the atmospheric air. But usually with the pollution in the atmospheric air, we should have actually significant percentage of carbon dioxide that is existing already in this atmospheric air. And this carbon dioxide, when it comes actually into this aqueous solution of potassium hydroxide, it reacts with it and it produces actually what we call the potassium carbonate, K2CO3. This potassium carbonate will just block the pores at the cathode. So in this case, actually, and it will stop the reaction, the ionization reaction at the cathode after some time. So this fuel cell is highly sensitive to carbon dioxide. So either we can use pure oxygen, that means we have to use air separation unit to separate oxygen for the fuel cell, and this is additional cost. And it also will reduce the efficiency. Otherwise, we can also just do a kind of purification process for the air in order to separate carbon dioxide. But this is will require additional cost in this case. We have another kind of fuel cell. We can have the phosphoric acid fuel cell, in which we have the electrolyte here actually is phosphoric acid, and the ions that transfer in this case allowed to transfer through this liquid electrolyte are the positively charged hydrogen ions. So similar to the proton exchange membrane, this also electrolyte allows the transfer of positively charged hydrogen ions from the anode to the cathode. Then we can have water vapor can be created in this case. The operating temperature of this fuel cell is about 200 degrees C, but this fuel cell is powerful. It can produce actually high power up to 1 megawatt, 1 megawatt in this case. But it has one disadvantage. It is not easy to start this fuel cell at low temperature, because this phosphoric acid actually just get freezed at low temperature. So we need just a kind of heat up to start this fuel cell at lower temperature, but it is highly efficient. It can approach efficiency of 85%. So as you can see, Sharab, the operating temperature is 200 degrees C. That means the water leaving here actually is leaving at high temperature, which is 200 degrees C. We have to have in this case, Shabab, a kind of cogeneration to absorb this heat in any other process, or we can pass actually this water in a steam turbine. It can drive a steam turbine because this water is existing at high temperature. We can pass it to expand in a steam turbine, and then we can connect this turbine to an electric generator to generate additional power. If you did so, and consider recovering the heat with the water outlet, the efficiency can approach about 85%. Otherwise, if you just left the water leaving at this very high temperature, the efficiency of the fuel cell can drop down up to 42%. But as you can see here, Shabab, in all cases, even if we don't have heat recovery, still the efficiency is much higher than the efficiency in case of internal combustion engine. Internal combustion engine, we cannot have efficiency more than 35% or something. Okay, so still fuel cell is a great option in this case. But this fuel cell is heavy. We have liquid phosphoric acid, so it's heavy actually, and it is powerful. But this power actually is a power per unit mass or per unit volume is low compared to the other fuel cell. And also, as we said, it is heavy, large and heavy, and also it is expensive fuel cell. We have another fuel cell with different electrolyte, which is a molten carbonate fuel cell. In this fuel cell, we have, in this case, the electrolyte is molten carbonate, and in this case, the ions that are allowed to cross this actually this electrolyte is the negatively charged SO3 ions. They can transfer actually from the cathode to the anode side. Then we can have the reaction to have, in this case, water out. But this fuel cell, to have this ions transfer through the electrolyte, we have to have supply of carbon dioxide to this fuel cell. And that's why this fuel cell, it can be working actually with natural gas, coal-based plants, in which actually the fuel itself has some carbon dioxide. So this one, it is not sensitive to carbon dioxide. We have seen this alkaline fuel cell is sensitive to carbon dioxide, and the carbon dioxide blocks actually the pore at the cathode. But this one, molten carbonate, can actually handle carbon dioxide, and it can handle different grades of fuel in this case. So carbon dioxide is main part of the reaction. At the cathode, we have carbon dioxide react with oxygen in the presence of catalyst. Then we can produce those ions. The ions will transfer through the electrolyte, and then we can have actually at the anode, we can react with hydrogen to produce water vapor and some carbon dioxide at the anode. Usually we have the flow of electrons. The electrolyte does not allow the flow of electron. We have to take the electron flow, the electronic flow through actually an external circuit. And this is the main job of the fuel cell, to have this flow of electron and generate electrical power in this case. One main drawback of this fuel cell is that we should have carbon dioxide at the outlet. So this fuel cell is not emission free. It results actually in CO2 emission in this case. But its temperature, its operating temperature is very high. It's a kind of 650 degrees C, which is a very high temperature. And in this case, we should use a steam turbine or recover the heat out. We cannot just leave the water leaving at 650, because the efficiency in this case will drop too much. If we recover this heat, it can approach efficiency up to 65%, and if we capture the waste heat, all of the waste heat, the efficiency can be approaching 85%. Can imagine here, Shabab, the energy, the efficiency, or the energy content in the hydrogen in the fuel, we can approach 85% of this energy, which means actually this system is very high, have actually very high efficiency in this case. Compare this value, 85 with the internal combustion engine. It's a kind if we use the hydrogen in internal combustion engine instead of fuel cells, that means we are just losing the energy in this case. Too much energy is lost in this case. Okay. The primary disadvantage actually of this fuel cell, it's durability, because the operation under this high temperature will reduce the lifetime of this kind of fuel cell. And also the electrolyte is phosphoric acid, is a molten carbonate, sorry, which is a kind of corrosive electrolyte. And that also will reduce its lifetime. We have the polymer electrolyte membrane, which we said this is called the proton exchange membrane. We talk about this. We said the electrolyte in this case is not liquid, it is just a solid membrane. And this membrane allows a transfer of hydrogen ions across the membrane from the anode to the cathode. And it blocks the transfer of electron, and that's why we have to have external circuit to have the flow of electron in this case. This Shabab solid polymer electrolyte membrane, which is solid electrolyte, this is actually more suitable actually for passenger vehicles, because its weight is light, and also it is effective. This membrane is highly selective to hydrogen ions, and it blocks the flow of electron, and it can approach efficiency up to 60%. And it can produce power output about actually 200 kilowatt. This kind of fuel cell, which we call it proton exchange membrane or polymer electrolyte membrane, it is actually the same. This is actually ideal actually potential. It has actually high potential actually for the application in the transportation and the portable power plant. We have also another kind of solid electrolyte kind, which is called actually the solid oxide fuel cell, in which we have a ceramic electrolyte. Ceramic electrolyte also allows the transfer based on its vacancies, the design actually of the lattice structure of this ceramic material. It allows actually the absorbance of certain kind of ions. Most probably those ions are the hydrogen ions, positively charged hydrogen ion, which allows them to transfer from the cathode to the anode. Then we can have the reaction of hydrogen and oxygen. Then it can produce water vapor in this case. One main advantage of this fuel cell يا شباب is the operating temperature is very high, which is 1000 degrees C. Usually our sequence يا شباب is just to produce hydrogen through steam reforming of methane or any other hydrocarbon fuel. We have the reaction with water vapor, then we can produce this hydrogen. Then we can take this hydrogen to the fuel cell to produce electrical power. But here, as the temperature, the operating temperature of the fuel cell is very high, that means we can combine actually in this case both processes, reforming, fuel reforming, the reaction of the fuel like methane with water to produce actually hydrogen in this case. This is the reforming reaction. It can take place on board on the same fuel cell. We don't need to have the reforming process separated to produce hydrogen. We can produce hydrogen in the fuel cell itself through the reaction with water vapor to produce hydrogen, and then this hydrogen is ionized inside the fuel cell in the presence of catalyst as well to produce hydrogen ions. Hydrogen ions can cross the solid oxide actually electrolyte to the other side, then it can react with the oxygen to produce water vapor. That's why شباب this fuel cell it can handle different kind of fuel. It can consider methane because it does the two processes: reforming of the fuel, reaction with water vapor to produce hydrogen, in addition to the process actually of the fuel cell to produce electrical power. We can ionize this hydrogen and also supply oxygen. Then we can have the reaction of H2 and O2, and we can produce electricity. So it can handle different kind of fuels. We can have methane, we can have ethanol in this case, and also we can have methanol. So it can handle actually different kind of fuel, and we can have onboard the fuel reforming plus electrical power production through the hydrogen fuel cell in this case. Okay. So it can also handle يا شباب natural gas, biogas, and different grades actually of fuel, and it can transfer coal, the gasified actually gas that we can obtain from the coal, which we call it synthetic gas. We can take it also to the hydrogen fuel cell to have both fuel reforming to produce hydrogen in addition to the electrical power production in this case. It's as you can see here يا شباب, the temperature is very high. That means we can use actually a cheaper catalyst because the operating temperature is very high. The reactions will be activated to be done at this very high temperature. We don't need a very high price catalyst. We can use any kind of special a cheap catalyst actually to have those reactions done. But it have some disadvantage. It have actually low startup, and it needs also شباب due to this high temperature. It's actually very high temperature, 1000 degrees C. It needs actually significant thermal shielding. We have to shield the fuel cell. So that's why شباب this kind of fuel cell we can use in the utility, in different application in the industry to produce electrical power. In those utility we can just provide this kind of thermal shielding. But if I use this one in the transportation in vehicles, then in this case we cannot protect too much about this very high temperature. So otherwise we have to spend some money to have a kind of effective thermal shielding to prevent actually it from harming or hurting the people. Okay, type this is a solid oxide fuel cell. Another fuel cell يا شباب it looks like the kind of liquid igniter that you have in your hand if you just have cigarettes or something. Usually you have it in your pocket, so that will be something looks like this one, but it will be actually for portable application in order to recharge your phone, recharge your laptop. This fuel cell we call it direct methanol fuel cell. It's something very small. We can have it is provided with liquid methanol, mixed actually with little bit amount of water to have this reaction at the anode oxidation. Methanol with water to produce the hydrogen ions that can cross the electrolyte. In this case, can cross the electrolyte to the cathode where we can have the reaction with oxygen to produce water in this case. And the overall reaction we can have methanol plus oxygen to produce water, plus this methanol have carbon, plus some carbon dioxide will be produced in this case. But this fuel cell شباب is very effective compared to hydrogen because to use hydrogen in a fuel cell, hydrogen actually is a light fuel. occupy big volume per unit density. It is not actually energy dense fuel. So using methanol is energy dense fuel. We can actually just store significant amount of it. Then actually we can using it in this fuel cell, it can produce actually significant amount of electrical power. But this, yani, depending on its size is very small. You can just put it in your pocket, yani. But with this size, it can provide actually continuous charging of about 3 to 4 hours, which you can use actually to recharge your cell phone or laptop. They can have actually those kind of portable fuel cell application. Okay. يعني you can look here يا شباب. This is يعني a video. You can look at it at YouTube. You can check how this kind of fuel cell can work. Here is يعني شباب a detailed comparison of all of the fuel cell that we have presented here. You can just look at this table. The advantage of the fuel cell, when we utilizing cogeneration, when we recover the heat out with the hot water, because fuel cells are working at high temperature. In this case, if we recover this heat, it can approach actually efficiency up to 80%. Also, power provided does not actually degrade over time, unlike the case of batteries. Batteries with time, battery need to be recharged from time to time, and after some time, this battery will not be able to work. Its operation actually degrade with time. But here, fuel cell is like internal combustion engine. As long as you provide the fuel, you can get actually power output in this case, and the performance will not be degrading too much with time. So that's why شباب, we call the fuel cell as fuel cell engine. We call it engine, like internal combustion engine, because this is a kind actually of engine that actually its performance does not go down with time, unlike the case of batteries. So as long as we supply the fuel, which is hydrogen, we supply oxygen, then in this case the fuel cell will be working in this case. Its operation is perfect. It's a smooth operation, and also it is very silent operation. We don't have any kind of noise or vibration like the internal combustion engine. Also, it reduces the harmful emission. In case of hydrogen fuel cell, it produces only pure water vapor plus heat plus electrical power. So we don't have any kind of emission. And also the size is reduced. The size of the fuel cell will be even smaller than the case of internal combustion engine. But the main disadvantage, which are under research, so we used to say شباب, that hydrogen still we don't have infrastructure for hydrogen, still its price is high, we cannot produce hydrogen. All of this from the past. Hydrogen is coming and research is going. We have infrastructure right now for hydrogen, but we need to spread it. We need to have, يعني almost hydrogen will be dominating actually the fuel infrastructure. So instead of gasoline station, it should be converted to hydrogen station. So that so the future شباب is not for the battery electric vehicle. The future actually is the hydrogen fuel cell. Even in civil aviation, and now Boeing and also Airbus started actually producing some version actually of airplanes that are working with hydrogen fuel cell. But يعني those airplanes at the initial stage, they cannot have actually many passengers. The volume of the airplane has been reduced because يعني also still fuel cell, we need hydrogen tank. This hydrogen tank has to be pressurized to high pressure, and it is heavy in weight. So this will reduce the overall volume of the airplane. But this is actually a kind of research. I think one company last week in the UK, they have produced actually the first airplane with 20 passenger seats. It has been produced and it is working with hydrogen fuel cell. So there is a lot of research is going in this direction, not only in the vehicles, on the ground level application, we have also in the airplanes, we need to have this kind of replacement of regular fossil fuel to be replaced with hydrogen. Hydrogen can be also originated from fossil fuel, but we just need to have hydrogen at the end. Okay. Type its price is still, it is expensive. We have we can say we have weak infrastructure, but infrastructure is developing, and also hydrogen price is still high, but also the investment in this field will reduce the hydrogen price. Hydrogen fuel cell is the future for the electric vehicle. General Motor was the first company actually to start using hydrogen fuel cell to drive an electric vehicle. And it looks like it's a battery electric vehicle, but in addition to this, we have to have hydrogen tank. Hydrogen, in order to be stored يا شباب in the liquid form, it has to be cooled down to a temperature of almost minus 225 degrees C in order to compress significant amount of hydrogen, because hydrogen have very high volume and it is low energy dense fuel. So in order to use actually significant amount of it in a small space, we have to pressurize it to very high pressure. This pressure يا شباب inside this hydrogen tank, it should be about a kind actually of 700 atmosphere, 700 bar. Okay, so it's a very, very high pressure in order to actually store a significant amount of hydrogen. But it is highly safe يا شباب because hydrogen have high diffusivity. So if we have a kind of leak in this tank or something, the hydrogen will diffuse in the air, and it should not result actually in direct ignition. But usually this tank is designed, Toyota have produced a version of Toyota car, which is Toyota Mirai, working with hydrogen fuel cell. This is actually, the design of this tank is highly safe. It has 3 layers, and it cannot actually, even if you just shot it using a gun or something, this actually bullet will not be affected. This tank will not be affected by this bullet. So you can imagine it can actually absorb very high pressure under severe situation. Even if we have accident or something, this tank will be able to survive and it will not result in any harm. This is يا شباب the hydrogen fuel cell electric vehicle. It consists of the hydrogen, the fuel cell itself, the fuel cell stack, which we have to have here. We have to have hydrogen tank in order to store hydrogen for the fuel cell. We have to have traction inverter. The electric power produced from the fuel cell will be just transferred to electric motor. But to control the operation of the electric motor, we have to have a kind of controller, DC to AC controller, to control the operation of the electric motor depending on the required load. So this controller is connected to the accelerator pedal under your leg, which will decide actually about the amount of electrical power and at a given volt to be provided to this electric motor in order to actually drive the transaxle, which just takes the power from the electric motor to drive the wheel of the car. Also, شباب, this hydrogen fuel cell, it needs the hydrogen coming from the hydrogen fuel tank, which is pressurized. We don't need actually to have a compressor in this case to pressurize the hydrogen. But for the oxygen fuel cell require oxygen also, and it requires this oxygen at a little bit higher pressure. So we have to have, in this case, we have to have a turbo compressor. We have to have a kind of dynamic compressor in order to compress the oxygen for the fuel cell. But now, as you can see, we have onboard production of electrical power, unlike the case of battery. Here also, شباب, we have battery. We have to have battery because under part load conditions, this battery can absorb the excess amount of electrical power and then it can deliver it later on. But the operation is mainly depending on the fuel cell in this case. Okay, so those are the components of the fuel cell. As you can see, this is how it works. This is the hydrogen fuel cell. It takes hydrogen from the hydrogen tank and it takes the air from the compressor. Then it can produce electrical power. This electrical power will be directed to the controller. The controller will be controlling the operation of the traction motor or the electric motor that can drive the wheels of the car in this case. Look at the component here, شباب, and the energy conversion. We have converted the chemical energy, which is the energy of hydrogen. We have converted it into electrical energy, which you can transfer it to the electric motor. And then through the electric motor, we can have finally this electrical energy is converted to mechanical shaft power. In most شباب of the fuel cell hybrid buses that have been produced, we have already, شباب, this is already in practice. We have hydrogen fuel cell cars. Toyota Mirai is a version which has been there actually for many years. We have also some buses are working with hydrogen fuel cell, but most of them are using the battery pack, which is nickel metal hydride. battery pack, which is used most probably by Toyota and the General Motors. They are using, actually investing very much in this kind of batteries. But now China is leading the advances in most of the batteries. Lithium ion and all of these batteries are led actually by the Chinese company. BYD also is leading, highly leading actually in this field, in the battery. And China taking the trend in order to produce not the fuel cell, but they are working on the battery electric vehicle. They can use have a kind of light. They are developing kind of light batteries which we can use actually in small cars. Then they can just produce a car with small price or little bit lower price compared to the other. And this is the Chinese series that they have to produce something with lower price. But they don't invest much in the fuel cell. Fuel cell cars are led by Toyota for buses and also for Toyota Mirai sedan car. They have been in the market for many years. But in order to produce a significant amount of voltage, enough voltage to drive the electric motor, we have to have a stack of a number of fuel cells. At least we should have a kind of 45 fuel cell in a stack in order to provide enough voltage for a medium-sized sedan car. Like Toyota Mirai, we have to have at least 45 fuel cell on board the fuel cell in a one stack in order to produce enough electrical voltage to drive the vehicle. Here is the arrangement, how we put the fuel cell with the powertrain system in an electric vehicle. We have indirect power system. Indirect power system is a hydrogen fuel cell. We call it fuel cell engine because it is an engine, as long as we provide hydrogen, provide oxygen, this will be converted to electrical power. And this engine, its performance does not degrade with time. Okay, so it's like internal combustion engine, but it is not. It is producing electrical power. So we supply the fuel to the hydrogen fuel cell engine. Then we can have the arrangement. Either we can have direct power system, indirect power system, in which we have the electrical power will be passed through DC converter, which controls the voltage. So that this voltage, this power can be either transmitted to the controller of the motor and drive the motor, or if we have a part load condition and we have excess electrical power, then we can supply part of this power to the energy storage system, which is the battery in this case. Another design for the fuel cell with the powertrain system. Fuel cell can be used directly to have the electrical power output directly to the controller in this case. But this is in case of large size, powerful fuel cell, in which this fuel cell can produce high voltage. This high voltage can be directed directly to the controller to just run the electric motor. But battery, anyway, battery should have DC controller to control the volt coming and leaving the battery. Otherwise, this battery will be destroyed in case if we have higher voltage in this case. So this is how we integrate the fuel cell engine with the powertrain system of an electric vehicle. Here is it. This is a comparison between the three of them. Battery electric vehicle, as you can see, working with battery. So its performance, the performance of the battery is going down with time, and at a given stage we have to replace this battery. It cannot work continuously. Unlike the case of internal combustion engine, as long as we are providing the fuel, the engine will be operating, and its performance does not actually degrade much with time. So it's almost constant with time. But its efficiency is low, between actually 25 up to 35%. This is the maximum efficiency of internal combustion engine. But if we consider the hydrogen fuel cell, efficiency can be more than 65, even it is higher than 60%, maybe 65 or 70%. We can get this efficiency using the hydrogen fuel cell. And its performance also does not go down with time. It does not require recharge like the battery. Just in this case, it requires constant supply of hydrogen plus oxygen. Then we can have electrical power output, onboard electrical power output in this case. Here is the version Toyota Mirai. You can look at this version. It's a very nice car. and also it can run. We don't have recharging gas, so with it is charged with hydrogen, and we can refill it in a kind of 2-3 minutes, even faster than refueling your car in a conventional car with internal combustion engine. And also it can approach a very high speed. And also it has the same performance characteristics of internal combustion engine, but we don't have emission in this case, and it is burning actually hydrogen in this case. You can look at it on YouTube, Toyota Mirai, which is the future actually. And Toyota actually, this kind of fuel cell electric car, battery electric vehicle, the advancement in the battery will be used later on in the hydrogen fuel cell. As you can see, in the hydrogen fuel cell, we have to have batteries as well. But the function of the battery is not to drive the power for the electric motor. No, the function of the battery is just to store the extra amount of electrical power. That's why the battery lifetime, when it is used with hydrogen fuel cell, will be elongated in this case, like the batteries that we are using now in conventional internal combustion engine car. So it will have actually long lifetime, and we can use any kind of cheap battery, not any kind, but we can use cheaper battery. But you can see here, in case of battery electric vehicle, the performance is going down with time, and at a given stage we have to replace this battery. So the future, Shabab, is the hydrogen fuel cell electric vehicle, not the battery electric vehicle. Okay, but battery will be there, especially for the coming decades. I expect to have battery electric vehicles there, especially the ones that are coming from China. This will be there for sure. But until we have well developed the infrastructure of hydrogen, until this time, we will see actually hybrid electric vehicle, conventional internal combustion engine vehicles, and we will see also battery electric vehicle. But once it comes to a stage that we have actually good infrastructure for hydrogen, so at this stage actually both of them will just disappear, and the market will be just dominated by the hydrogen fuel cell. Here is the comparison, Shabab, between battery electric vehicle. Battery, we do have batteries. It need electrical power. We have hybrid electric vehicle, or plug-in hybrid electric vehicle. Hybrid electric vehicle, we have regenerative braking to generate some excess electrical power while the braking. Then we can use this electrical power to drive the motor and drive the vehicle, at low speed condition. But in this case, hybrid electric vehicle is considering the oil as a feed and considering internal combustion engine. Plug-in hybrid, we have both of them also. We have internal combustion engine and we have also battery, but it requires external charging in this case. The battery pack is bigger in case of plug-in hybrid compared to the hybrid electric vehicle. So we have both of them in this case, electrical power source to supply the battery with external supply of electrical power, and also we have the internal combustion engine, which need actually the oil supply in this case. And finally, we have fuel cell electric vehicle, in which it has to be supplied with hydrogen. We have also battery, but we have fuel cell here in order to produce electrical power. Okay. So, Shabab, sorry, can I have just 1 minute?
It's okay. Okay.
Sorry, Shabab, it was an important call. So here, Shabab, as you can see, this is the comparison between all of them. You can see here hydrogen fuel cell. It shares with internal combustion engine its durability. It have actually, let me just maximize this one. You can see here, hydrogen fuel cell, it shares with the internal combustion engine its long drive range with refueling, one refueling time. quick refueling, also stable at different vehicles with different vehicle size. Also, it have limited weather impact. We can initiate or start the engine in the cold weather. But internal combustion engine, it results in greenhouse gases emission, and it is less efficient. It shares also the hydrogen fuel cell. It shares some important feature coming from the battery electric vehicle or electric vehicle, like it has zero emission. Also, we have instant torque. It is quiet and also high fuel efficiency. It has very high efficiency, and it has domestic fuel source. But this is, it just avoid the disadvantage of the battery electric vehicle, which is mainly the charging time and the limited range, also the heavy weight of the battery, and it is sensitive to the weather. We cannot start easily this kind of vehicle under cold weather condition. So as you can see here, Shabab, and currently we have this conventional internal combustion engine without even regenerative braking. But as you can see in the market right now, we can have the hybrid electric vehicle with regenerative braking. So the next step, battery electric vehicle is always will be there, but for who want to take it, with its disadvantage. But the market is right now dominated by hybrid, not dominated by hybrid electric. Right now it is dominated by conventional internal combustion engine cars, vehicle. But next, inshallah, next decades, 10 to 20 years, you'll find hybrid electric vehicle is dominating the market. This will be transferred most probably to the plug-in hybrid. So battery is an option for almost for a small size sedan car. Small size car, it can work with battery. Because if we went to large size car, in this case, we have to have bigger battery pack, and its cost will be very high in this case. So the market will be transferred after the hybrid electric vehicle to plug-in hybrid until we have good infrastructure for hydrogen, and all of this will just disappear, and it will be dominated. The market will be dominated by the hydrogen fuel cell electric vehicle, and this is the future issue. This is the future fuel cell electric vehicle. Technology already is there. You can see some cars and some buses are working with the hydrogen fuel cell, but the number of fuel cell stations is still limited, and also still we have some problem with hydrogen transportation and the storage, but research is ongoing, and we should go actually in this direction. Any question, Shabab? Any question regarding this?
Yes, Doctor.
Yes.
I didn't have a question.
It's okay, Shabab. So so inshallah will this part, Shabab, the last part here is the solar car. I think you should have heard about the solar car that we have here. There was one senior design student group of students. They have designed a solar cell car, and even you can try it at your home. So this is something easy. We have to have in this case photovoltaic cells. Photovoltaic cell it consists of some semiconductor, which most probably silicon. When the sunlight is just coming on this photovoltaic cell, it can actually convert, it can freeze the electron in those semiconductor material, and it can release some flow of electron. We can take this flow of electron and we can just use it in the battery, provide it to a battery, and then this battery through a controller, it can drive an electric motor to drive the wheel of the car. The flow to the battery has to be controlled also by what we call the power tracker, which just protects the battery against the high voltage. It's a kind of DC controller to control the voltage coming from the photovoltaic cell, which supplies the battery with the electrical current. You can design something like this one. We have some version of a small solar car, and the component are the solar array, which is the photovoltaic shield, which we put it above the car to receive actually the heat coming from the sun and convert it to electrical power. And then we have to have the power tracker to control the flow of current to the battery, and then this battery actually is used actually to control, to provide the current to a controller. This controller controls the operation of the electric motor here from the controller, and the electric motor can drive can drive the wheel in this case. Even if you have a toy at your home, if you have a young brother, in this case you can just try to get a toy of any car, just to get axle, some tiny gears, and small electric motor. You should have somewhere in some toys. We have the wheels, and you can add some solar panel. In this case, you can design it, and then we can have connected to the electric motor to drive the whole of the car. Yeah, you can get a body chassis, just you can play it, and you can get actually this kind of car. You can do it, okay? So this is a solar car. But solar car here, if you look at some limitations, usually the heat coming from the sun, the energy coming from the sun is have a concentration of about 1000 watt per meter square of energy is coming in 1 hour when the sun is at its peak condition. So while actually, let's say at the noon time, when the sun is at the peak condition, in this case, the energy coming from the sun is about 1 kilowatt per meter square that we can get from 1 meter square of photovoltaic fuel cell in 1 hour. Okay. But if we have a solar car, then in this case, the car size may be around the surface of the car, maybe let's say 8 meter square, 2 meter by 4 meter, which is very long, but let's consider it 8 meter square. That means from the sun under the peak condition, we can get about of 8 kilowatt hour per meter square. But this is the input energy coming from the sun. The photovoltaic have efficiency about 12 to 18% to convert this energy into electrical power. So at the end with this efficiency, we can convert this electrical energy, solar energy, which is the heat input energy. We can just get about 0.7 to 1.5 kilowatt per meter square per hour. Sorry, per 8 meter square, which is the surface area of the car, which is very low amount of energy can be inputted to the car in this case. So this is a kind of huge limitation. We cannot have this car also responding to the load variation. This is something tiny, and I think it will not go into deep application. This is something for some very small uses in campus or something. So this is can be used. As the advantage of the solar energy, it's renewable, environmental friendly. We can fix it anywhere. It don't produce actually harmful emission. It doesn't damage the earth. So it's perfect. But it has some limitation. We cannot. It looks like it requires a lot of space. Only it can run when the sun is there. So at night you have to search something else. Look at the battery. It doesn't produce much electricity. Because per unit meter square, the amount of energy coming from the sun with this low efficiency will be very low in this case. Current devices which are utilizing are expensive. The efficiency of the system depending on the location on the earth. Some countries, cold weather countries, I think this will not be applied anymore. But it can be applied here. We have the sun is very strong, but it will be for limited application. Okay. That's all يا شباب.